So, good evening, everyone. It's a pleasure to welcome you all again into this another webinar related to the AI-driven software architecture. We had one session last time, I think in the month of February or January, I think related to the Azure AI and machine learning. So, in this session, I'll guide you through the exciting and rapidly evolving space where software architecture meets the artificial intelligence. So over the next hour, we shall explore how AI is no longer just a feature, but it's becoming a fundamental part of how modern systems are designed, built, and evolved. So in other words, we can't ignore artificial intelligence, as simple as that. Okay, so whenever we are thinking about architecting any software, any application, mostly we think it in terms of APIs, REST APIs, front-end part, database part, Kubernetes, and other things from the deployment perspective. But we till now got conditioned to consider or think about AI as a separate entity. But those days are gone now. So this session is to touch upon that aspect, how we can make AI as a part of our architectural paradigm. Okay. So whether you are a developer, architect, trainer, or student, this session is designed to give you practical insights. We'll discuss about the architectural patterns, hands-on demos, and real-world lessons on integrating AI into scalable cloud-native applications. So I encourage all of you to think how you can apply these concepts in your own system. So let's get started and dive into this world or session about AI-driven software architecture. So this is a brief introduction about myself. I'm working as a tech applications manager in SLB Pune. Uh, I have strong exposure to the Microsoft.NET technologies and evolutionary architecture, machine learning models, and optimization algorithms also. Then I work across different industry, financial services with JP Morgan, Travelers. Then in retail, work with Best Buy, insurance domain, work with Shub, and currently I'm working in the oil and gas domain. You may be finding me writing articles, technical articles on different platforms like code projects and dev community. Mostly I write around machine learning, then meta heuristics algorithms and the application development. Now this is our brief agenda. I'll be introducing the concept. We'll discuss the core principles. Well, as we are talking about architecture, so no discussion is complete without talking about the patterns and the designs. Then we will take up certain demos or certain live demos, I would say, where we would see how those concepts we brought to the reality. Then we can discuss the takeaways, and then I'll open the floor for the question and answer. Now, before even we talk about AI-driven architecture, let us first understand, do we need this concept? We need that answer, right? We need that conviction of our mind first. Do I need to think about AI-driven architecture, first of all? So what I did is to emphasize this concept, I have taken some real-world examples. So let us take one case of retail and e-commerce. So here we are discussing the mispersonalization. So what happens is traditional recommendation engine. Recommendation means whenever we are visiting any shopping or e-commerce website, we do see a lot of recommendations get pop up either at the bottom or top right corner of that screen. And it most of the time it is saying like based on your past shopping experience, you may be interested in purchasing or shopping this particular item. So those are the personal recommendations which application is showing you. But today, the way they are getting designed and driven is totally different than it was getting or it was getting designed before the pre-AI area or era. So here I have taken one example from of my Walmart. There are other retail giants also in West, Sears and JCPenney. So what happened is in their case, they also implemented the recommendation engine, but that engine was not based on the AI or artificial intelligence. It was totally based on the manual merchandising system and the manual rules. However, during the same time, Amazon introduced the AI recommended system, personal recommendation system, and it has captured massive market share through personalized product suggestions, and it has also increased the average cart value and the user engagement. And it resulted in billions of dollars potential revenue loss to the giants like Walmart, Sears, and JCPenney. Second example I have taken is the fraud detection. So I think 10 or 15 years back, I think I don't remember the exact date, but this one of the Australian bank, Danske Bank and HSBC, they got involved. Somehow the frauds got detected there and millions of dollars got lost. It doesn't mean that they were not having the fraud detection system in place at that time. It was there, but it was not strong enough to identify the very smallest or very intricate transactions and alert to the stakeholders well in advance. So that again emphasizes the need of AI-driven architecture in the software applications. Third example I have taken is the logistics. So we all remember the COVID-19 era, right? Where everyone was struggling to find out whether entry to a particular city is restricted or it is prohibited or it is allowed, even if it is allowed, during what time of the day it was allowed, right? And anyway, if we need to supply certain items, we have to bank upon or rely upon the logistics. So there were companies we were not having that intelligent logistics or routing mechanism in place, and it resulted in the delivery delays and unsold inventory. On the other hand, there are big players also. For example, Amazon, right? Amazon also ship products. But since Amazon has that intelligent routing mechanism in place, Amazon fared or played a, I mean, they didn't realize that much loss. Why? Because AI they already incorporated in their system. And the final example I have taken is the customer support. Today also, when we call any customer support, depending upon what question I'm asking to the executive may not find it, may not get the intent of my question. And now, when we are integrating AI in those customer support system, now it becomes, I mean, it is more smoother than what it was there 5 or 10 years back. So these are the four areas which highlighted the importance of integrating AI in those areas where a common person or like us get exposed to. Okay, so I hope this slide made us think about how AI-driven software architecture is important. Now, let me introduce this concept now. So let us begin with the central question: what is AI-driven software architecture? So here on the slide, you could see the first three from the left. There are three different systems which we all are aware about: rule-based systems, then traditional three-tier architecture system, and the event-driven architecture. So traditionally, software systems are built with static logic. So you define inputs, logic, and outputs. But AI changes this paradigm. Instead of hard coding intelligence, we train it. AI-driven architecture treats machine learning models, data pipelines, and decision system as first-class citizens. These aren't just add-ons or plugins. They influence how your app behaves in real time. So think of a recommendation engine or a fraud detection service or AI assistants. They adapt based on patterns in data. The architecture to support this kind of adaptability needs to be modular, scalable, and feedback aware. So in this session, we shall explore how this concept translate into real world applications using cloud native tools and hands-on demos. Now, let us begin with the foundational concept, the AI first design mindset. So in traditional software development, as you can see in this diagram, we typically start by defining explicit rules, business logic, and workflows. We build apps that execute predictable behavior based on human authored code. But in an AI first approach, we reimagine that process. Instead of hard coding or logic, what we do is we design systems that can learn and adapt based on data. This means that we think about the data and we also think what is coming out of that data. What are the hidden patterns are there in that data, because AI can learn from it and how the system will improve over a period of time based on these hidden patterns as well. So in other words, we are not building static logic, right? We are building learning systems, and these systems consume data, they produce intelligence and evolve over a period of time. So, for example, instead of writing 100 if and else statements to filter fraudulent transactions, we train our machine learning model to detect them based on patterns in the data. And that model needs to be part of architecture from day one. We cannot just later on plug into our architecture. So, here are few implications if I, of an AI first mindset. So models are first class components, just like APIs or database. You design with data flow in mind, ingestion, storage, pre-processing, and real-time feedback. Your system supports retraining, evaluation, versioning, and real-time feedback collection as well. Now, most importantly, this architecture adapts to the new data, okay, over a period of time. So the core idea is we don't think of an AI as a feature. We think it as a design principle. So as we move forward, we shall see how this mindset influences architectural choices and deployment patterns and the tools we use. Now, now that we have explored the AI first mindset, let us talk about how we build such systems. And that starts with modular and scalable infrastructure. So in traditional applications, you might have a single app server or database, maybe additional few services as well. But AI systems are inherently more complex. Why? Because they don't just run, they learn, evolve, and scale independently. That means your architecture needs to be modular, where each part can operate and scale on its own. So let us break it down this philosophy. So when we talk about a well-structured AI system, we often has a data ingestion pipeline, processing model, a model training component, and an inference engine or a model API. You can call it as well. Then we also have a mechanism to monitor the feedback. We also may have retraining loops. So all these components, even though they are part of this AI system, they are not tightly coupled with each other. They are loosely coupled. What does it mean? It means that they can be independently deployable, they can be independently scalable, they can be, and they can all be controlled through a version change. So for example, your model inference service might need GPU support and scale based on query volume. However, in case we are talking about data pre-processing job, which may need to run periodically, not all the time, we may we may we may decide to run it in a batch mode also, and we don't need to scale it in real time. So by decoupling this, we what we do is we basically avoid the bottlenecks and make our infrastructure more efficient and fault tolerant. So this is where containers orchestration platforms like Kubernetes comes into picture. So in other words, what we can do is we can package each component in its own container, deploy them independently, scale each part based on demand, and even roll out updates or rollbacks without affecting the rest of the system. And and this is all is required when we are talking about the scalability. Now, when we say scalability, we don't just mean load on the system, right? Because AI workload scales in multiple dimensions. For example, more users means more inference API calls. More data means more frequent retraining. Larger model means more compute intensive operations. So as you can see, every area, every subdomain which I am going to pick up, it is leading me to a different aspect of my, it is, sorry, it is forcing me to think about different aspect of my system. Okay. So, and by integrating all these components together, what we get a flexible, resilient AI infrastructure that we can evolve over time. Even if we add new models or we upgrade old ones or we fine tune certain components, we can still be sure that we are not breaking down the whole system. So in other words, if we can manage to integrate put modularity, flexibility, and scalability together, that means we are on the way of building a future-proof system. Now, feedback loops and continuous learning. So this is one of the transformational or important principle in AI-driven architecture. So feedback loops and continuous learning. Basically, here the key idea is AI systems aren't statics, right? As I said, they don't stop learning once the model is deployed. In fact, the real world keeps changing. For example, user behavior change, data gets change, and new patterns come out of that change data. So without adaptation, even the most accurate models may degrade over time. And this is known as a model drift. So what do we do about that then? So we should architect the system such that it should learn from their own performance. And this is where the feedback loops comes into play. So let me walk you through this cycle. So data is collected from various sources. For example, the data source can be logs, user interactions, sensors, etc. Now that data is used to train or fine-tune machine learning models. But these models are then deployed into production, often as an API or embedded logic. As user interact with this API, the behavior generates new data, and this data is tracked and analyzed to understand how the model is performing. Now, based on the performance metrics, for example, accuracy, precision, and latency, we decide whether to retrain the model or refine the model. Now, this improve model we again deploy, and the loop continues. So, this continuous learning cycle actually beneficial for the model health also. And but if we think from the or if we look at it from the architectural point of view, what does it mean? What my system supports? So my system support capturing the labeled or implicit feedback. For example, when the user click on a certain link, how many times he becomes successful? How many times the clicking of the link leads to the failure? Okay. Then monitoring tools. Is my monitoring tools capable enough to detect issues? Is it detecting a model drift or a data drift? Then we may have pipelines to pre-process and retrain model as well. And with the help of versioning, we may able to roll back. Uh, we may able to implement self rollback mechanism also. And we often automate, for example, ML ops workflows are there, right? Which help us to orchestrate the entire loop, which you can see on the screen. So let us take one example. For example, you are building a fraud detection model for an e-commerce platform. So initially, you may find that it is performing very well. But as the fraudsters adapt, for example, these fraudsters are changing their tactics. That means your model's accuracy may get dropped. So that means if you don't have a feedback loop in place, you won't even notice the different tactics over a period of time which fraudsters are going to implement. But with the continuous learning in place, your system detects the drift, flags the model for retraining, and improves based on the latest fraud patterns. And that's the power of self-improving systems which I'm talking about. So, in other words, AI systems shouldn't just work well today, they should be designed to improve themselves tomorrow on their own. So, when designing AI driven architecture, we need to ask ourselves how will the system collect feedback? How will it detect decay? Decay means degradation in its own performance. How easily can I train and redeploy the model? So, these are not just questions restricted to the operational category. These are basically the core architectural decisions. So, in summary, continuous learning turns AI from a project into a product. And once we take care of all these things, that means if we implement all these self-improving system capabilities, you will see that slowly our project is evolving into the product, which is adapting faster and it is getting better and better again over a period of time. Now, let us look at some of the architectural patterns that support the core principles which we just discussed. So these patterns help us decide how and where to embed AI into our system. So first is model as a service. So model as a service is one of the most common patterns. You host your train model as an API and call it from your application, decoupling inference from the application logic. The second is event-driven architecture. So event-driven architecture are ideal basically when predictions are triggered by real-world events such as receiving the message in a queue or uploading a file. Then there may come a time when we need to decide between the batch interface or the real-time interface because such system, for example, chatbot responses need the real-time inference, right? While others run model scoring on large database periodically. In some cases, it is smart to combine rule-based logic with AI, using rules as fallbacks or filters. Then finally, we have human in the loop pattern, wherein which are very helpful in healthcare or legal, where AI provides suggestions, but humans make the final call. So, as I said, we have certain demos also line up in this webinar. We'll be discussing most of these patterns in this demo. Now, design consideration for integration. So, once you pick up the right pattern, the next challenge is integration. And this is where the real world complexity kicks in. So, first, your data strategy is critical. AI is only as good as the data you feed it. We all know that, right? The more good, more diverse, more relevant data you're feeding to your model, you're bound to reap the benefits of it in the longer terms. So basically, we are striving for the clean, labeled, diverse, and lineage traceable data sets. Then there is a model lifecycle management. So it's not just about building a model once, right? We need tools for versioning, rollback, and redeployment as well when the performance dips. Then we need to use standardized interfaces like REST or gRPC so that application team can consume our models like any other service. Then, as I talk about the model drift and data drift, we also need monitoring in place, right, which can detect model drift and data drifts. Because as I said earlier, models may get, models will decay if it get unchecked. So we need logging, performance metrics, and retraining triggers as well. And finally, security. Why? Because ML models are valuable intellectual property, rather, right? And there it can be targeted by anybody. So we has to ensure secure APIs, we need to encrypt traffic, and use proper authentication for inference and training endpoints. Now that we have seen how AI can be embedded into software architecture, it's time to focus on how to operationalize it at scale. Okay, so that's where the cloud native infrastructure and MLOps practices become essential. So this slide is structured into three key layers that together make scalable AI system possible. Now let us talk about the first block, that is CI/CD and CT. CT means continuous training. So think of this as the day offs for AI workflows rather. That can be the good similarity you can take. So we start with source code and notebooks versions in Git that fits into the model training and tuning done using the ML frameworks like TensorFlow or Python. Once the model is trained, what we do is we run validation and testing, including A/B testing also wherever needed. Now, these validated models are then packaged and pushed to a model registry such as MLflow. Finally, they are deployed to the production, often automatically with the help of pipelines, CI/CD pipelines, like any other applications which we manage. Now, this entire flow ensures models are developed, tested, and deployed with consistency and automation, just like traditional code. Now, all of this is built on cloud native infrastructure, which allows for scalability, resilience, and cost efficiency. We use Kubernetes to orchestrate model deployments and scale inference workloads dynamically. Serverless functions are great for event-driven AI tasks, for example, Logic Apps, Azure Logic App, Lambda as well, AWS Lambda. So they are good for image recognitions or file upload, triggering events on the file upload as well. And then finally, we manage these platforms like Azure ML or SageMaker or Vertex AI as well, Google Vertex AI, simplifying the lifecycle by offering built-in tools for training, deployment, monitoring, and collaboration. So these are the popular platforms which I have just put down here. Now, of course, so deployment is just the beginning, right? Once the model is live, it, as I said earlier, it has to go through or we has to have a constant monitoring in place. So we use monitoring dashboard to track accuracy, latency, and throughput as well. Because model drift detection may help us in identifying where the model performance is started degrading due to the introduction of new data patterns. We implement role-based access control as well. We implement audit logging as well so that we remain we ensure compliance, transparency, and security as well. Because there are certain areas, for example, healthcare, finance, and there are regulated industries also wherein they expect our system remain compliant with the regulations. So this layer gives us visibility, control, and governance over how models are performing and being used. So in short, combining cloud native architecture with MLOps pipelines help us scale AI application, continuously improve models, and ensure reliability and governance in production. So this is how you transform AI from prototype in a notebook into a resilient enterprise grade system. Now it's the time for implementation. So I have just to explain the concept. The as you remember right from the previous slide, model as a service was our first design pattern. So aim of this demo is to expose a train ML model. For the sake of demo, what I have done is I have taken one Hugging Face sentiment analysis model. Okay, and then we are going to invoke it with the help of REST API. So fast API. So let me walk you through the code first. I think I have. This is the one. So these are the libraries which we have taken up. This we need for web framework. These are the cores because when we execute our code, right, the request may get blocked. The request coming to the our API may get blocked. That's the reason we need to have this library cores modular transformer is for Hugging Face we are using. This is one of the BERT based bidirectional encoding related models, distill BERT. Then this is the API REST point we are taking, and this is a default text I have put. I love this webinar. And what it is doing is it is sending me the sentiment, whether it is positive or negative. Then, as you can see, that also then confidence with what confidence it is making that statement, and the text which we have given it. Okay, and these are the exceptions. Now, let me run this for you. Uh, this is CMD. Let's open this. We are going to start the API first. I'll just paste command over there. Yeah, it will get started. After that, what we will do is one interface we have created a simple HTML page which will capture the sender request and capture the uh, sentiment. So this is a by default text. I love this webinar. For example, when we are running it, uh, the Hugging Face model, sentiment analysis model is saying that the sentiment is positive, and here you can see the request which it has received. Okay, you can change it also. For example, I find it confusing. So anything we can say. So yeah, it has correctly predicted it's a negative sentiment. So the basic theme of showing you this is model as a service is to that how we can let me take this how we can use the model ML model invoke is through a API and pass the result to the front end. So to emphasize this design pattern model as a service, we have taken up this demo, this use case of sentiment analysis. Now, moving to the next demo, that is event-driven AI with real-time feedback. So you remember we also have this design pattern. So here what we are doing is, here, let us say you are building a live chat, for example, and you have a comment section, or you might be developing a multiplayer game wherein content moderation needs to happen instantly because anybody can type anything, right? Which is toxic in nature, which is socially not acceptable. So that means we need a way to moderate that comment which user has just put, right? So the user interacts with a web or mobile client as they type or submit a message. That message is automatically sent to backend using a WebSocket connection. Because why we are using WebSocket? Because we need feedback in real time. Okay. Now the fast API based moderation service receive this message, then forwards it to the Google's Perspective API. Now so Perspective basically is a part of Jigsaw. I think Jigsaw is a subsidiary of Alphabet, I believe. And to so I'll show you something. So you need to go to Google Cloud. You need to create a credential there. When you request for a credentials or default means a project gets created, and then you can create a API key. So this is one part. Then you has to visit the perspectiveapi.com. There you need to submit one form that you need to access the text moderation or comment analyzer API. And after half an hour or 1 hour, they send you. I mean, they give you the approval, and then only you can access this. I mean, you can allow uh, your API to access the perspective comment analyzer API. So this bit long process is there to which we have done to develop this demo of text moderation. wherein based on the user input on in real time, Google's Perspective API comment analyzer service is detecting whether the text is toxic in nature or whether identity attack means a person is being targeted on its race, religion, country, anything that is known as a identity attack. Now, let us quickly look at the uh, yeah text moderator. So this is the sample code. Uh, this all we I just discussed web framework, and this is a perspective API key. So I have put my key because it we cannot expose it right in the environment variable. This is comment analyzer is a model name, and we are invoking the version 1 alpha 1 of this model, and developer key is perspective key. Static discovery means we would not like to use the cache version of the model. We would like to use the real time one. Then it expect the request in this format, and what we are expecting is we expect this model to return toxicity, how severe it is, and are there any score related to the identity attack. Okay. And then if it is greater than 70%, then we are flagging that value as well. And this is the WebSocket related code which we have put for the, and we are running it on 8001 for the real time communication. Now, let us move to its implementation. Let me close this one now. I'll close this as well. The model as a service related one. We'll go here, text moderation. Again, we'll follow the same process. We'll invoke our endpoint. Okay. Yeah. Now, again, we have one simple interface created. Now, I will type some thing. Let us put some good thing first. Let us say I think this idea could work or something like that. Uh, I am confident about this task. We'll turn on the real time so that in real time it can analyze, and it will give you the response depending upon how fast the response we are getting from that from the model perspective model. So this is a positive sentiment I have put. That's why you see toxicity is less. Now let us say some borderline constructive feedback. For example, we can say that this is this is not much not much helpful, but um, improve it next time. So as you can see, real time, I am getting the feedback from the API based on, and the values are getting changed. So you can see the toxicity percentage has increased because I have used this sentence, not much helpful. Okay. Now, let us use one toxic sentence. For example, I'm just changing it. You are worst. Nobody, nobody like you, for example. So here, this is a very harsh sentence, and as I said, it is analyzing it, and it takes time to receive the response. So we'll move to the third demo. Till that time, it will pull back the response and display the result there because this toxicity percentage is fluctuating. Okay. Now, a bit more about this event-driven with real-time feedback, as you can see in the screen, depending upon the tone of the sentences and all, or the intention or the tone in this the text of the where user is commenting or pasting. This model real time detects whether it can be allowed or it can't be allowed, and it helps us in maintaining the social media platform. In other words, so this is one of the architecture pattern which we have seen. Now, third one is human in loop decision flow. So in this demo, we highlight a concept that is becoming increasingly essential in real world AI applications, human in the loop decision. So the goal is to ensure that AI doesn't work in isolation, especially in high stakes or ambiguous contexts where human judgment is still crucial. So the user submit text for classification. This could be a customer review, support ticket, or any domain related content. A pre-trained transformer model, that is Distilbert, which we have used for the sentiment analysis also. Same model we are going to use in this demo as well. So what we are expecting is our model should classify the text, whether it is positive or not, along with the confidence score. However, we are not going to blindly trust the model's output. The human sees this AI's recommendation and human will decide whether to accept it or override it. So this from the crux of this concept of human in the loop decision flow. Okay. So whether the model is aligned, whether let us say our opinion is aligned with the model or not, it gets logged into the feedback system, including the confidence score and the timestamp. If the human decision differs from the model's prediction, we flag that entry as needs retraining. Over time, these logs can be used to fine tune or retrain models to be more aligned with real world judgments. So key takeaway here is this creates a accountable, transparent AI pipeline. It bridges the gap between automation and human trust. Most importantly, it enables continual improvement with real world feedback. So, human in the loop is not just a safety net, it's an active mechanism to improve your models, build user trust, and meet compliance standards. Now, let us take look at this demo. So, let us first visit our toxicity. So it is still, let me off it and analyze it again. We'll see what value we get. Yeah, see, we have again analyzed it and the toxicity percentage got increased. It has really flagged it out. So this was an example of real-time event-driven architecture design patterns. We'll move to the third one now, human in the loop flow. Again, I'll close the previous API. Let us go to this demo now. CMD type Python dot py. So let us open. Hmm. It is restarting. Okay. So let us say this boy is good. I'm just typing one sentence and I am asking model to classify it. And it has classified it as a negative statement. Okay. So suggested category is negative, but confidence is zero. Now we know that this sentence is not uh, sorry, it has categories it as positive. That means model is predicting it with the correct value. But I feel that this is a negative sentence. Just an example. So what I would do is I'll submit my decision. So I submitted that this is a negative sentence. And my feedback will get log here only. So that means at this time AI predicted negate it as a negative, but uh wait a minute. Or let me do that again. I just classify this document. So suggested category is negative, and I also agree to the model, for example, and that's the reason I also submitted negative. So so I agree with model's prediction. Now let us change it. Let us say this boy is bad, for example, boy is bad. So again, the model has given the negative. I agree to that. I'll submit my decisions. Fine. View feedback log. So there are two occasions where the model has predicted is as negative and the confidence score was 100. But in the first case where I said the boy is good, if you notice the confidence score was less, confidence score is 0. Okay. And here for now to this sentence, same sentence, my opinion is different. I am saying I am not agree with the models because this is not right. So I am submitting it as a positive. Okay. So here model says negative, but I said positive. So here I am flagging that need, that when that there is a need for our model to train on such kind of data, and that's why I'm saying needs retraining. So this is an example of human in the loop model, wherein we can submit our own decision, our own answer in relation with the model's response as well, so that we collect that data, identify where model is not performing as per the expectation, and retrain it further. So this is a demo related to the human in the loop decisions. Now let us take a step back and talk about why AI driven architecture is not just exciting, right, but also demands data. Uh, it's also demanding. For example, data quality issues are there, right? So poor quality, bias, or incomplete data can lead to misleading results. Many projects fail because data wasn't properly cleaned, contextualized, or governed. Then we also seen the model drift. So even the best models decay over time. What worked last month might become irrelevant as user behavior or external factors evolve. That's why continuous monitoring and retraining are crucial. Integration complexity. Embedding AI into real world system is harder than just training a model. You have to connect it with APIs, pipeline services, and ensure it's all version deployed and monitored in sync. AI workloads can get expensive, especially for real-time inference. There is often a trade-off between speed, accuracy, and operational cost that architects must continuously optimize. AI often touches sensitive data, so role-based access, encryption, audit trails, and compliance with regulations like GDPR and HIPAA can't be ignored. And this adds another layer of complexity. AI decisions that feel like black boxes can lead to distrust as well. So users and even regulators now expect explanations, transparency, and human oversight, especially in critical domains like healthcare or finance. In short, AI-driven architecture is powerful, but only if we address these hidden cracks head on with smart patterns, governance, and a user-centric mindset. Now, let us talk about the best practices. Now that we have seen the challenges, let us shift our focus to what makes AI-driven architecture work effectively. The best practices that separate successful implementation from failed pilots. So, first is treat your models as products, not just prototypes. Build them as standalone services, what we called model as a service, so that they can be version monitored and reused across teams or applications. And this also allows us to improve the scalability and take care of separation of concern. AI shouldn't be static. The best systems are designed for continuous improvement, collecting feedback, tracking accuracy over time, and triggering retraining when drift is detected. Think of it as building a living learning system. Break your system into logical units, for example, model training, inference API, feedback ingestion, and monitoring, so that each piece can scale or evolve independently. This makes your architecture cloud native and resilient to changes. And as I said earlier, security is not optional. Why? Because most of the time our model deals with the sensitive data. So from day one, we need to apply role-based access control, logging, model versioning, and if your domain requires it, we need to incorporate fairness and explainability checks as well. That comes under the explainable AI topic. Now, this is especially critical in industries like finance, healthcare, and public services. Manual deployments uh, manual deployments may not scale our models properly, so we has to automate our ML lifecycle using ML ops tools like ML flow, or cloud native stacks like Azure ML, Vertex AI, or SageMaker pipelines. This brings the rigors of DevOps to our AI projects. Finally, not everything should be fully automated, like we have just seen in the last demo, right? In high risk domain, let humans review or override AI decisions. This improves trust, safety, and provides valuable training data for future model iterations. So these practices may look simple, but together they can create the foundation for a scalable, ethical, and future-proof AI-driven software architecture. Now as we come to the end of this session, let us take a moment to reflect on what we have explored today. So first we discuss how AI is no longer a bolt-on feature. It is a first-class architectural consideration. From planning to deployment, the way we design system is evolving to make space for intelligence at the core. Then second, we look at how scalable architecture must support modularity, real-time inference, and learning feedback loops, because AI thrives on iteration, not on finalization. And third, we saw how responsible AI is just as important as intelligent AI. That includes transparency, governance, and collaboration across engineering, data, and business teams. So to build impactful AI-driven system, we must think beyond code and cloud. We must think about users, feedbacks, ethics, and evolution. Every architectural decisions which we make from today onwards, we has to think how your models are served to how feedback is captured. It is because that is going to shape user trust and business outcome tomorrow. So thank you for joining this session. I hope you walk away not just with demos and slides, but with a mindset shift toward building system that learn, adapt, and respect the world they operate in. And I would love to hear your thoughts, questions, or comments on this. Thank you. Yeah, Nandadeep, we can now open the floor now for questions or any comments attendees may have. Yeah, Ani, am I audible? Uh, oh,
Will we get the copy of the PDA, this slide?
yeah, I'll share. I'll post it in the.
Okay, thank you.
Any questions? Thanks, Ujwal. First of all, very nice perspective. I was looking at it being into architectural role from last 3 4 years. I can definitely relate. Whatever things you were saying, irrespective of technology, what we are going to use or what we are proposing to our customer. Like why AI is going to be the base part of it, right? And the other way I can relate it is because as we are seeing, right, the boom wherein people wanted to just have AI enabled product or AI enabled solutions and all of that,
Mhm.
it becomes mandatory that if there is no AI word in there, they are sometimes not interested at all, basically, to talk about it, to justify the solution which we have provided. Because first
Exactly.
thing,
Yeah,
first thing is they would ask, like, okay, how this can be, how I can incorporate AI, what we can use to do this, that kind of thing. So definitely,
yeah,
a very, very nice session. And I was going through everything. But yeah, Sunil, go ahead and ask your questions.
Yeah, thank you. It's a nice demo also. I have one
yeah.
question regarding that. Means, let's say, if you have existing, system, and which is well architected, it's well functioning right now, and but looking at the future. So, how we are looking at, there are things like we can re-architect, or we can lift and shift with some, we can override few things here and there. So,
Mhm.
for example, I was working with some Australian client Medcash. For them, which we have designed system where uh, they're pulling the the pause data from across the world. Not across the world, from the Australia region, from the different regions. So right now here, in terms of AI enablement system, right? So when we're talking about we should enable the AI. So do we really need to think? This is a very fundamental question I'm asking. Do we really need to think that we need to re-architect the whole thing, or is there something which we can cohesively, just put some add-ons on the top of that, where we can, join these solutions. For example, AI-enabled solution, which will then work, cohesively with the existing architecture.
Yeah. So fundamentally, there are two aspects to your question. You have a properly running system in place.
Correct.
I would like to embed AI in it. That's the
Correct.
question.
Correct.
The first thing we should ask is, what is my intention of introducing AI? what I want to leverage from AI. Like let us say you have a social platform. Just an example.
Mm.
People put toxic comment like we have seen. Now I would like, and I don't have time to moderate it offline. I want to build a system wherein a model will tell me the moment person has started typing, model will flag it inappropriate content, block the user or block the comment. It will not allow him to post it. This is just an example. So on the similar line, we need to or you need to first identify if I integrate AI to in my system today, what I am looking to get from that AI. So that use case determination should happen first. Once that is identified, then we have to start at a POC level. The reason is I don't want to break my system. Rather, I would like to evolve over a period of time. Get that POC done, address the show to the teams or to the stakeholders, and then you can parallelly see the options you can see. I mean, can I plug it in, or my architecture doesn't allow me? Like you have just seen some architectural patterns, right? Because you have
Mm.
front end, you may have REST API. So that means AI, and you are now that means you can separately develop your AI model and just plug in or invoke it through the REST API. So this is a minimal, easiest way to incorporate AI without breaking a system. So that is how I
Okay.
will advise. Identify the use case and start at a POC level, and then depending upon the feedback from the stakeholders, architects as well, then you evolve over a period of time. Sunil.
Okay. And yeah, got it. I understand that. I mean, first the identification will happen in terms of, for example, I'm talking out more from the financial system.
Hmm.
Then what would be the AI enablement will help me to grow the business in
Hmm.
terms of right quality or the monetary benefits likewise. So my next question is, I understand that part. So your next question is like, when we talk about the security of the data in the rest or data in the transit, right? The kind of security which we are currently following in terms of, the encryption or hashing or maybe, the way we are, save our data. So when we are following the AI model, that will remain the same as it is, right? I mean, that will not going to change.
So, like as I said, again, it
Or
depends upon the use case. Let us say you want to track the fraudulent
let's say, I
transaction.
mean, the data is very important, like it's a financial data,
Yeah, yeah, exactly. That's what.
so
So ideally, it has to be separate. Okay,
mhm,
separate. And as I said, let us say you have 1,000 transaction records. Pick up two or let us say 10 records or as a data. You can even create a synthetic data as well because your aim is to see that POC first, and then you can replace the data with the real time over a period of time. And let us say once the model is live, I mean it is performing well, then comes the question of whether should I feed my live transaction data to the model or not. Okay, and there are a lot of security mechanisms or measures which we need to take, I think. And that measures, as of now, I am not that much aware. Maybe encryptions or some other things. But yes, that is going to be the like initially in the demo I said, right? Model deals with the sensitive data most of the time. So it is
mhm,
very important for us before even I start doing the things, how am I going to safeguard it? Am I going to host it in some different cloud region? Am I going to, let us say, maintain a gap of 3 or 4 days in the live data and the response which model is giving me? If can I afford this delay of 3 or 4 days? What if a fraudulent transaction or scam happen during that time only? That is another
mhm,
side of it, right? So that means
correct.
definitely I would like to feed the real-time transaction data feeding to my system, but at what cost? Do I have that budget to implement that costly measures of safety as well? Or I would have my budget in place first and then only I'm going to move ahead. So a lot of if and buts we need to manage, Sunil, because as we are saying that in architectural domain or architect, we always deal with trade-off. There is no single answer. But
Mhm,
yes,
got it.
I got your point. Data is security is important. We need to think about it and then only move ahead. But it will not stop you from creating a POC, right? As I said, you can create a synthetic data as well, similar in nature,
Yes.
and
Yeah, I
develop
mean,
your model.
and thank you.
Yeah.
Yes, I got it. I mean, for example, wherever for the current system which are architected, we are deployed in the secure network, right? On the top of that, we are having the OAuth and authorization, all these places also there. So that
Mm.
will definitely will take care of that once we deploy this AI model inside that system, right? So private
Right.
endpoint and everything, right? In the same virtual network, that
Mm.
should be able to take care of it eventually.
Right.
Correct. Thank you, Vijay.
Thanks.
Yes, and please go ahead.
Hello, am I audible?
You are, yeah.
Yes.
Yeah, thanks for this session. So, one question: what is the associated cost when we implement or add an AI system with an existing application? And if the application is deployed not in cloud, is it possible or how difficult it will be to include an AI with this existing application?
Okay. So if you are going to use the existing model, let us say Hugging Face has a lot of models available. If you are going to use pre-built model, then you are just invoking it in your existing application, even though it is not a cloud-based application. However, if you want to write your own model, you want to train it with your own data, then given the volume of the data which we expect a model to get trained on, positive cases, negative cases, definitely you would need something like cloud repository to store that data and get your model trained. So it depends on the answer of that question, Shine.
Okay. And any idea of what kind of cost it may increase? Means
No, so
approximate
cost,
idea.
see, I'll tell you, if we are going to use, let us say, any Azure AI search is there, right? The cost is very minimal. Azure base, for example, if you're using any Azure base, cognitive services are there. You want to, let us say, you're uploading an image and you want to detect what that image contains. So you can plug and play it, for it to invoke, for you to consume that Azure based cognitive services. It is not mandatory that your application has to be on cloud.
Hmm.
So, and the cost is very minimal, I would say. Of course, it depends upon then the how at what scale you would like to use it. Yeah.
Okay. Thank you.